So what is the permutation? Permutation, we know these are the arrangement of the arrangement. If there are n things, we take the r at a time, then permutation, we represent this. This is equal to, we know, n minus 2 up to n minus r plus 1. This is equal to this. If there are n things, the arrangement are when we take out of n r or r at a time, then permutation of these are this. We know this. Now permutation also defined when the arrangement are repeated. Also, if there is n things are repeated r times, then total repeated r times, then total permutation will be total permutation will be nr. When repeated, then very time we have the total permutation or total arrangement this. And we take, if the repetition is not allowed, then we have npr equal to nn minus 1, n minus r plus 1. These are the permutation definition hai. These are the only the arrangements. And if we have the permutation on the circle, then we have to fix something on this circle. We take the number of lines, number of lines, and n are the points on it. Take we number of lines will be nc2, and number of triangles will be nc3 on the circle, and number of the quadrilateral are nc4. If there n are points on the circle, then we have these rearrangement permutation we have in this way. Now, if the persons are seated, then one person is fixed. The total arrangement are factorial n minus 1. There are total number person who can sit on the round table, and these are the factorial n minus 1. Now, if you take the square, we make, suppose n is any square. The number of the squares will be what? The number of squares will be n into n. When we take this, when r is equal to 1 to n r square, and number of the rectangle from n into n area, so the n into n, then the number of the rectangle r sigma r is equal to 1 to r cube. if there is a rectangle of the this measurement and its length and pitch, the pitch unit is the breadth, the number of rectangle will be np upon 4 into n plus 1 into n plus p plus 1. P plus 1. Number of the rectangle will be this. Now number of in this area, in this measurement, number of squares will be sigma r is equal to 1 to n, sigma r is equal to 1 n plus 1 minus r and n p plus 1 minus r. These are the number of the squares in this measurement. We have many formulas related to the permutations. These related on the words, the numbers. These are related. Now we come to if you take the n things of one type and second type, then group may be made among one type and second type. We have the number of the permutation this. We know this. We have read in the 11th class. Now, what is now comes to combination. What is the combination? Combination is the making the group or the team, or the parties or say the samitis. These are calculated by the combination, where the order plays no part, no important part. But in the permutation, there plays an important part. Their order plays an important part. You remember this. Now we come to the some combination are the selection, which are only we select the group, but in the order is not the important here. If we take the x from the n, we make the group x. Suppose we make group x from n things, then this will be n things of x of n things. Then this is equal to r thing. If in a group there are r number, then x into factorial r is equal to the total number of the arrangement. There is we represent by this. The total number of the permutation taking r at a time from the n, we represent this. Permutation, if there is x, then x is represented by this. Therefore, NPR is equal to factorial r. This is called the NCR. When we take the group R from n things, then combination is NCR. That is equal to this. This is the relation between the combination and the permutation. Now, what is the against relation between them? Here in the permutation is always greater than the combination, greater than, always greater than. This is always greater than. Permutation is always greater than, permutation always greater than the combination. And the order plays important part in a permutation. Order plays a important part in permutation, but in a combination, it is not so important. These are the relation between the combination and the permutation. We deal with the arrangement, with the words, with the numbers, with the digits. We deals with the numbers. We deals with the letters. We deals with the element. But the combination, we deal with the group parties. We deal with the group party in permutation. We deals the number of words, number of words, number of numbers, number of words, number of arrangement, while in permutation, in combination, we deals the group parties, and Samiti and the teams. We deals with the teams. Here, these are the difference between the permutation and the combination. We deal in the combination. We deal with the group parties, samitis, and teams. There is no important role of the order. But in the permutation, we deal number of the numbers, number of the arrangements, number of the words, number of the letters. We deal with in the case of the permutation. And the order of the number plays a vital role, important role. Plays a important role in the permutation. Now this is the difference between them. Now we have the combination when the repeated combination are calculated from from the coefficient of xn in x0 plus x1 plus x2 and so on and r. The coefficient x in this, we collect the coefficient when the combination calculated from the combination are calculated when is repeated, when combinations are repeated. Then we collect from this relation as we distribute the n things into the r percents. Or we solve the equation by taking the x plus x1 xr and to the equal to n. Solution of the equations we collect, we find out by the combination, by method of combination. If there are, we take here comes n plus r minus 1 cr minus 1. Total number is this. Then we does not, if we take at least one, suppose the n are prices are distributed among the persons, if we take at least one, then we have the formula this. We have the formula this, and we can collect the power of xn in x1 plus x2 plus x3 and so on. In this, we take the coefficient of x in this. Now there are some questions we are solving. Now we take the question number 1. And we formed from the letter word maximum if two consonants cannot occur together. You see here the consonant here are m, x and triple m. In this consonant are 3 times m and x 1 time. And vowels are a, I and u. Now you say that they should not come together. Consonant should not come together. Then we have to arrange the vowels first. And we vowel have 3 a, I, o, u. These are the vowels. We have to arrange this. And in between them, we arrange the consonant. The consonant we have put in 4 places. And the vowels are placed in the 3 places. The vowel can be arranged in a factorial 3 ways, because there are 3. And between them, we arrange the consonant. Therefore, there are 4 places. But m are 3. M are 3, we have to divide the m. These will be the consonant can be arranged by this way. The total number will be total arrangement will be factorial 4 upon factorial 3 into factorial 3 is equal to factorial 4. Where factorial, we know 4, 3, 2 and 1. Factorial 4 defined this way, and factorial 0 is always defined 1. Now, in this way, the total arrangement is this. Now, take the vowel first, A, I, U, and between them you arrange the consonant. Those vowels can be arranged in factorial 3 ways, and the consonant in 4 places. First place, second, third place, your fifth place, and seventh place. We arrange in this way, in between the vowels. First, second, third, and fourth places are for the consonant, and they can be arranged in the factorial 4 ways. Consonant can be arranged in the factorial 4 ways, but M are repeated 3 times. Therefore, we have to divide by 3. Therefore, the total number will be factorial 4 upon factorial 3 into factorial 3 means factorial 4, where factorial 4 is this. Now, this is clear to the student. Now, we come to the question number 2. To show that the NPR is equal to this. Now, you should know. We know what is the NPR, the total arrangement. We know n into n minus 1, n minus 2, and n minus r plus 1. We know this NPR. Here only we have the r times multiple. We have multiplier or r times by substituting 1 by 1. 1 and 1 substituting, we have the formula of the permutation. We know this. Now we take the other side. Other side what? Other side what? This is n minus 1 PR, n minus 1, n minus 1 P R minus 1. This is the right hand side, n minus 1 PR plus R into R, यहाँ R है, ये given to us R, plus R into P n minus 1 R minus 1. We are given this. We have to prove this is equal to the NPR. Now, what this says? This says start with the n minus 1 and n minus 2 up to n minus 1 minus R plus 1. This is equal to this. And what this says? This is equal to start with the n minus 1 and n minus 2 up to n minus 1 minus R plus 1 will be there. Now this will be there. Now what this is? This is there. We have written up to n minus 1 cancel out R. Here what we get? Here we get n minus 1, n minus 2 up to n minus R plus 1. You see here. This is left hand side and this is right hand side. We have this. Now take the common up to n minus 1, n minus 2 up to n minus R plus 1. Before this is n minus R plus 1. We can take common n minus 1, n minus 2 up to n minus R plus 1. We can take, because before this term, the term will be n minus R plus 1. So what remain here? Here remain this. Only n remain. So therefore, bring n here in the first place. We see this is what? This is the same thing as in the left hand side. Therefore, we can say that NPR is equal to n minus 1 PR plus R into n minus 1 PR minus 1. This is the solution to the question number 2. Now this is all the students know this. We are only simply we are solving here. Now we come to the question number 3. Sum of all 4-digit number that can be found by using the digit 2, 4, 6, 8. Now sum of the 4-digit number that can be found by using this. Repetition is not allowed. Now he wants sum of the all numbers, 4-digit number. Then this number will, if you put the 2, then we find out the sum. We put the 2, then 3 will go on rounding. These will go on rounding, and in the factorial 3 ways we can. If we take this, all 3 days, all will take in the factorial 3 ways. If you take 6 first place, then the 2, 4, 8 will give the arrangement, give the arrangement factorial 3. Therefore, this will give us the numbers factorial 3 into 2 plus 4 plus 6 plus 8 or into multiply by 1, 1, 1, 1. Multiply 1, 10 की square power, then की 1 power, 10 की square power. In this way we get. Now, sum is this. You see here the question number 3. Question number 3, here the factorial 3 means 6. Factorial 3 means 6. They will go on rounding. The number is what? Here you see number will be 2, 4, 2, 4. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6 plus 8. This will be the number, and here will be, we get 10 की power 1, 10 की power 2, 10 की power 3 and 10 की power 4. We will have this. Now what is here is 6. Here is factorial 3 means 6. 6 into 2, 4, 6, 6, 12, this is 20. Here what is this here? This is question number 3. We are dealing with the question number 3 because the 3 digit will take round and the factorial 3 ways. Now the sum will be 4 numbers, sum will be this. Sum will be this. Now what is this? This is 20 and 6. Here 1 plus 10 plus 100 plus 1000 plus 10,000. This is 6 into 20 into what is it? 10,000, 11,000, 100 and 10 and 1. This will be this 1, 1, 1, 1, 5 times. Now multiply this by 120, 1, 1, 1, 1, 1, 6, 5 times. This will be the answer. Sum of all the 4-digit number. 0 का 0, 12 का हासिल के 1, 13 हासिल का 1, yeah, again 1, again 1. This will be the, and we have put the 0 here, 12, हासिल का 1, 12, 13, हासिल का 1, 13, हासिल का 1, 12, 13, and here will be the total number. My love, 1,33,000 and 320. This will be the sum. This will be the sum. This is the sum of the 4-digit number. If we take 2, then the 3 digit will remove here and give the total weight factorial 3. Therefore, these are 6 and sum of the unit digit is this and sum of will be this we multiply by this by 1, 10, 100, 1,000 and 10,000. This will be the sum of the 4-digit number. This is the required solution to the question number 3. Not greater than 4,000, which can be found this. What are the total number when the digits are repeated? When the digits are repeated. Number greater than 4 but not greater than 5, which can be found with this. What are the total number if the digit is repeated? If it is repeated, we have not written here. Here, digits are repeated. Digits are repeated. This digit will be repeated. Now, in both ways we solve this question. Suppose the digits are repeated. Suppose the digits are repeated, then the first place can be filled by 1, 2, 3. Not 4. That will be greater than 4,000. If we take the first place, at first place 4, then this will be greater than 4,000. What he say? The number greater than 1,000, but not greater than 4,000. So therefore we can't take the 4 at a time. But if we take a number is repeated, we take the 4, only one number is there, that is 4, 0, 0, 0, because digits are repeated. So there will be one number we will have to last. The first place can be filled by 1, 2, 3. 1, 2, 3, then 3 ways. In the 3 ways. Now second place can be filled by repetition is allowed, then second place can be in 5 ways. In 5 ways. Similarly, third place also can be filled in 5 ways. And the fourth place can also be filled in 5 ways. In 5 ways. Now total number is 3 into 5 into 5 into 5, मतलब 375. The total number is 355 into 375. But digits are repeated, therefore at last 4,000 will come also. At last 4 will come, because digits are repeated. If we put the 4, then 0 is repeated 3 times, then this will also one arrangement, one wage can be added. So therefore total wage are 375 plus 1, 375. Again, you see here, this is this is you see here, now digits are repeated. Now the number at the first place will be greater than 1000. Greater than 1000, and this and we take if the 1, then the 30 is repeated again, then first place may come. But this may come. But what he wants? He wants greater than 1000. Therefore, this will come also. This will come also. 1000 will come also. 1000 will come, sure. Because digits are repeated, then we have to subtract this. The third required number will be 376 minus 1, again 375. This will be the required arrangement, required number of the ways. Required number will be 375, because numbers are repeated. So if we put the 1, then 0 may be repeated, because 0 are in the middle, not in the first place. Therefore, the number is 1000 is also here, comes here, will appear in this way. Taking the 1, 2, 3, then 1, 0, 0 will come sure at the first place, at the first number. Now this will have to subtract. Now subtract the 1, the required number will be 375. In this way, if we second place we fill in the 5 ways, third place also, and the first place can be filled the second place 5 ways, third place in 5 ways, and fourth place in 5 ways. But these are not having the number 4. 4 he gets not greater than 4000. Therefore 4 will become, and our number is repeated, the 4 and 0, 0 also come, but in this way, in this method, this is the 4000 not coming, not appearing the 4000. Therefore, we have to add this number 1 also of the 4000. The number will be 376. Now again, the first place 1000 have appeared. If we fix the 1, then 3 digits will come, because number of digits repeated. That 1000 will come. So you have to subtract. What he says, the number should be greater than 1000 and not greater than 4000. Therefore, this will number 1000 will have to subtract us. In this way, we have the required number 375. This is the solution to the question number 3. Now we come the question number 4. 5. In a circus, there are 10 cages for the accommodating the 10 animals. Out of the 4 cages are so small that the 5 out of 10 animals cannot enter into them. Now 5 animals cannot enter in the 4 cages that are small. Therefore, we have to adjust the 5 animals in the 6 cages. That can be done in the 6P4, 6P5. That can be 5 animal can be accommodated in 6p 5 is. 5 are so big animals which are not entering in the 4 cages. They are small. Rest 6 we can fill the 5 animals in this way, 6p 5. And total now remaining the 5 we have to adjust in the 5 cages also, because the 1 cage remain empty, 1 cage remain there. The 5 animals can be for animal rest 5 animals can be accommodate in 5 cages. So therefore total number will be factorial 5, P5 factorial 5 and 6p5. Then this will be the total number of the arranging the 10 animals in the 10 cages in which the 4 are small, where the 5 animals cannot enter. The total number will be this. What is this? This is 120 and this is what? This is 720. So we will have the total number 2, 12 24 हासिल के 2, 12 7 84, 86. These are total number. These are the total number of the accommodate all the 10 animals in the 10 cages. This is the correct answer. Because the 5 animals can be accommodated in 6p5, because there are 6 cages are big. The 5 animals can be accommodated in this way. Now the 5 we have adjusted. 1 cage remain and 4 small remain, where the 5 remaining animal can be accommodated. The that will done in the factor 5 is. Therefore total number will be 120 into 7 to 6. This will be the number. This will be the number, total number of the accommodating in the 10 cages. The rank are 1 to 10. 1, 2, 3 up to 10. Now he say can be ranked such that A1 is above the 8, 10. The rank does not affect if the rank comes to first or rank comes to 10. We put the first the first place A1 or the A10, the rank 10 at the first place. There is no difference. Therefore, the number will be in the question number 6. There is no difference. There is no difference. Question number 6. Question number 6. There is no difference if a rank is put at first place or 10th place. There is no difference. Therefore, the total number will be put at the first place or at the 10th place. There is no difference. There is total number of ways arranging this, taking this is factorial 10 upon 2. There is no difference between the first rank and the 10th rank putting at the first place or the last place above the maybe A1 come, or A10 may also be come above the A1, and A10 may come, है ना, ये may come, it may come above the A10, or A10 may come above the A1, no difference. Therefore, we have to divide by 2 by arranging the rank factorial 10 by 2. So, total number will be this. Now, we come to the last question. On football team championship, there are 1-5-3 matches. Every team plays one match with each other. How many there are participating? Now, we are going to find out the team. Now, team are play each other only one match. Therefore, we can say, suppose the N are the team. In other team, the NC2 will be equal to 1/3, because team always play with each other. मतलब two parties can suppose in our team. Suppose in our total team, the matches will be this. NC2 will be total matches. So here we are given 1-5-3. The total football championship, there are 1-5-3. So this is equal to 1-5-3, or n minus 1 factorial 2 is equal to 1-5-3, n into n minus 1 is equal to 2 into 9 into 17. So this is the 18 into 17. Now n should be 18, n should be 18. अर्थात team 18 है. 18, there are the team, total team are 18. This is clear to the student. Now we solve the more question about the permutation combination next day.